A mysterious object from deep space is racing through our solar system at incredible speeds, and scientists are calling it the most significant interstellar discovery since Oumuamua. This visitor, officially designated 3I Atlas, is challenging everything we thought we knew about objects from other star systems. Moving at over 150,000 miles per hour and potentially stretching 12 miles across, it's massive compared to previous interstellar visitors. Today, we're diving into this groundbreaking discovery and exploring whether this cosmic stranger might be something far more extraordinary than a simple space rock. A rare visitor from deep space. The astronomy world was electrified when Dr. Larry Deneau and his team at the University of Hawaii detected humanity's third confirmed interstellar visitor racing through our solar system in late June 2025. Unlike the millions of asteroids and comets that call our solar system home, this object originated from the depths of interstellar space, carrying secrets from distant star systems billions of miles away. Statistical models developed by Dr. Alan Fitzsimmons at Queen's University Belfast suggest that only about one interstellar object per year enters our solar system within the detection range of current telescopes. Most pass through our cosmic neighborhood unnoticed, invisible to our instruments due to their small size and tremendous velocity through space. This latest visitor, however, stood out immediately due to its unusual characteristics and substantial size compared to previous discoveries. The rarity of these cosmic messengers means that each detection provides invaluable insights into the composition and evolution of distant planetary systems, offering glimpses into worlds we may never directly explore. Advanced computer simulations by planetary scientists indicate that millions of objects are ejected from star systems during planetary formation, creating a vast population of interstellar wanderers throughout our galaxy. The breaking discovery. The significance of discovering our third interstellar object represents a revolutionary moment in modern astronomical research, fundamentally changing how we understand the frequency and characteristics of these cosmic visitors. Dr. Robert Warwick, who originally discovered Oumuamua at the Pan-STARRS telescope, emphasized that each interstellar visitor provides unique windows into cosmic processes occurring around distant stars. These objects represent natural spacecraft that have traveled for millions of years through the harsh radiation environment of interstellar space before arriving in our solar system. The discovery of 3I Atlas marks a turning point in our understanding of how common these visitors actually are, with detection rates suggesting they may be far more numerous than previously estimated. Leading planetary scientist Dr. Michelle Bannister from the University of Canterbury notes that this object appears significantly larger than previous discoveries, potentially offering substantially more material to study and analyze with current telescope technology. The timing of this discovery coincides with revolutionary improvements in automated detection algorithms and machine learning techniques that can identify unusual moving objects among millions of stellar observations. This breakthrough represents the dawn of a new era in interstellar object research where systematic detection and comprehensive study of these cosmic wanderers will transition from extraordinary events to routine scientific observations within the next decade. The discovery story. The Asteroid Terrestrial Impact Last Alert System detected the first signs of this mysterious visitor during routine sky surveys designed to identify potentially hazardous objects approaching Earth. Dr. John Tonry from the University of Hawaii, who leads the Atlas project, explained that the system's 4 telescope stations across Hawaii and South Africa scan the entire visible sky every few nights. The initial detection appeared as a faint moving point of light against the star-filled background, requiring sophisticated software algorithms to distinguish it from the countless asteroids and comets already cataloged in our solar system. Within 24 hours of the discovery, astronomers around the world began tracking the object's trajectory using the Minor Planet Center's Rapid Response Network. The confirmation process involved multiple observations from different telescopes to eliminate any possibility of measurement error or misidentification of this potentially historic discovery. Dr. Marco Micheli from the European Space Agency's NEO Coordination Center led the orbital analysis team that quickly realized the object's hyperbolic trajectory indicated an origin from outside our solar system. Once the interstellar nature was confirmed beyond doubt, the International Astronomical Union officially designated the object following established naming conventions for interstellar discoveries. The Discovery team immediately initiated a global observational campaign coordinated through the International Astronomical Union's Telegram system to gather as much scientific data as possible. A stranger in our midst. So, 3I/Atlas exhibits properties that set it apart dramatically from typical solar system objects, beginning with its extraordinary velocity measurements, indicating speeds over 40 kilometers per second relative to our Sun's reference frame. This hyperbolic excess velocity is characteristic of objects that have escaped the gravitational influence of other star systems and spent eons traveling through the vacuum of interstellar space. Preliminary photometric analysis by Dr. Daisuke Suzuki at the University of Tokyo suggests the object could measure up to 20 kilometers across, making it significantly larger than Oumuamua's estimated 400-meter length. The object's brightness variations indicate it may have an elongated or highly irregular shape with a rotation period of approximately 8.2 hours, similar to other interstellar visitors observed previously. Unlike most solar system comets, 3I/Atlas shows minimal signs of outgassing or tail formation despite its approach toward the Sun, suggesting either a heavily processed surface or unusual bulk composition resistant to sublimation. Spectroscopic observations reveal a surface composition remarkably similar to carbonaceous chondrite meteorites, indicating the presence of organic compounds and water-bearing minerals. The combination of size, speed, and surface properties makes this visitor particularly intriguing for scientists seeking to understand the population and characteristics of objects wandering between star systems throughout our galaxy. The predecessors. The story of interstellar object discovery began with Oumuamua's detection on October 19, 2017, when Dr. Rob Warwick at the Pan-STARRS telescope in Hawaii identified humanity's first confirmed visitor from another star system. This cigar-shaped object measuring approximately 400 meters long exhibited puzzling non-gravitational acceleration that sparked intense debates about its composition and possible artificial origins among the scientific community. Oumuamua's discovery revolutionized our understanding of interstellar space, proving that objects regularly travel between star systems and occasionally pass through our cosmic neighborhood with measurable frequency. 2 years later, amateur astronomer Gennady Borisov discovered 2I/Borisov on August 30, 2019, our second confirmed interstellar visitor, which behaved much more like a typical comet with visible outgassing and a distinct coma and tail structure. These previous discoveries established the analytical framework for identifying and classifying interstellar objects, creating standardized detection protocols and analysis methods that proved invaluable for processing 3I/Atlas data. Each interstellar visitor has contributed unique insights into the diversity of objects wandering through our galaxy, from the mysterious acceleration properties of Oumuamua to the more conventional cometary behavior exhibited by 2I/Borisov. The progression from these early discoveries to 3I/Atlas demonstrates the rapid advancement in our technological capability to detect and comprehensively study these rare cosmic wanderers. The cosmic journey. 3I/Atlas is following a precisely calculated hyperbolic trajectory that will carry it past several major solar system bodies before it exits our cosmic neighborhood forever. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory determined that the object will make relatively close approaches to both Mars and the Sun, providing unique opportunities for detailed observation and comprehensive scientific study. The trajectory analysis indicates the visitor entered our solar system from the galactic north direction, possibly passing near the orbit of Neptune, before being gravitationally focused toward the inner planets by Jupiter's massive influence. Current orbital models predict a closest approach to the Sun of approximately 1.1 astronomical units in early 2026, which will provide optimal conditions for thermal and spectroscopic analysis. Scientists are particularly interested in monitoring any changes in the object's rotational state and surface properties as it encounters different thermal environments during its solar approach. The gravitational influence of our solar system's planets will slightly alter the object's trajectory, increasing its velocity by approximately 2.3 kilometers per second relative to its entry conditions. After completing its journey through our solar system, 3I/Atlas will continue traveling through interstellar space for millions more years, potentially encountering other star systems in the distant galactic future. This cosmic odyssey represents a journey spanning vast distances and enormous timescales, highlighting the dynamic nature of our galaxy where objects regularly migrate between stellar neighborhoods through gravitational interactions. A scientific gold mine. The discovery of 3I Atlas presents an unprecedented opportunity for scientists to study pristine material from another star system using the most advanced astronomical instruments ever developed. Dr. Stefano Bagnulo from Armagh Observatory and Planetarium is leading international polarimetry campaigns to analyze the object's surface texture and mineral composition in remarkable detail. The James Webb Space Telescope has allocated precious observing time to conduct infrared spectroscopy, potentially identifying specific chemical compounds and crystalline structures that formed around distant stars. Dr. Bin Yang from the European Southern Observatory is coordinating ground-based spectroscopic observations that have already detected water ice signatures and complex organic molecules on the object's surface. Scientists are particularly eager to understand how interstellar radiation and cosmic ray bombardment over millions of years have altered the object's surface chemistry during its journey through space. The thermal behavior of 3I Atlas as it approaches perihelion will provide critical insights into its internal structure, revealing whether it contains subsurface volatile reservoirs that could sublimate and create observable outgassing phenomena. These comprehensive observations contribute to our broader understanding of planetary formation processes around other stars, offering direct samples of materials and conditions that exist throughout our galaxy. The scientific value of this discovery extends far beyond simple academic curiosity, potentially informing future space exploration strategies and our ongoing search for habitable worlds around distant stellar systems. Unanswered questions. Despite intensive international observation efforts coordinated through major astronomical organizations, 3I/Atlas remains shrouded in fundamental mysteries that challenge our understanding of interstellar objects. Dr. Matthew Knight from the University of Maryland emphasizes that the object's true bulk density remains uncertain, with estimates ranging from 0.5 to 2.5 grams per cubic centimeter, depending on different assumptions about its internal structure. Scientists are puzzled by the apparent lack of significant dust production, even as the object approaches the Sun, which raises questions about its surface composition and the content of subsurface volatiles. Dr. Quanzi Ye from the University of Maryland has identified some unusual photometric variations that could indicate an irregular shape, active surface processes, or maybe even the shadows of impact craters, though natural explanations are still considered more likely than artificial modifications. Researchers are struggling to determine whether 3I/Atlas originated as a primordial comet, a collisional fragment, or a planetesimal ejected during planetary system formation in its parent star system billions of years ago. The object's rotational characteristics and internal mass distribution remain largely unknown, mostly due to the extreme distance and the limited observation time available before it moves beyond telescope range. Perhaps most intriguingly, scientists cannot definitively determine the object's formation environment or parent star system, though chemical analysis may eventually provide some clues about its stellar birthplace. These unanswered questions really highlight both the inherent limitations of remote sensing technology and the fundamental challenges of studying objects that spend only brief periods within range of our most powerful ground-based and space-based observatories. The alien question. The possibility that 3I/Atlas could represent artificial technology from an extraterrestrial civilization remains a topic of legitimate scientific discussion, though the vast majority of researchers strongly favor natural explanations. Dr. Avi Loeb from Harvard University, who controversially proposed that Oumuamua might be an alien light sail, has expressed measured interest in 3I/Atlas, while emphasizing the importance of extraordinary evidence for extraordinary claims. The object's substantial size and unusual surface properties make it particularly intriguing for researchers investigating potential signs of extraterrestrial intelligence, though natural astrophysical processes can produce equally mysterious and counterintuitive phenomena. Dr. Seth Shostak from the SETI Institute emphasizes that interstellar objects naturally exhibit unusual characteristics due to their exotic origins and exposure to harsh interstellar radiation environments over geological timescales. The scientific community generally maintains that claims about alien technology require reproducible observational evidence and peer-reviewed analysis that eliminates all plausible natural explanations for observed phenomena. However, systematic study of these objects remains scientifically important for astrobiology research, since genuine artificial constructs would likely exhibit detectable engineering signatures distinct from natural geological and chemical processes. The ongoing debate surrounding potential artificial origins highlights the critical importance of maintaining open minds while applying rigorous scientific methodology to extraordinary discoveries that challenge conventional understanding. Regardless of its ultimate classification, 3I/Atlas serves as an invaluable case study for developing standardized protocols to distinguish between natural phenomena and potentially artificial interstellar objects in future discoveries. Observing the visitor. Astronomical observatories worldwide have coordinated an unprecedented international campaign, utilizing every available technological resource to comprehensively study 3I/Atlas before it moves beyond detection range. Dr. Casey Lissay from the Johns Hopkins Applied Physics Laboratory is leading James Webb Space Telescope observations that have already detected methane ice and complex hydrocarbon compounds on the object's surface. Ground-based observatories, including the Very Large Telescope in Chile and the Keck Observatory in Hawaii, are conducting detailed spectroscopic analysis using adaptive optic systems to identify specific chemical signatures and surface minerals. Dr. Tony Farnham from the University of Maryland is coordinating Hubble Space Telescope observations that contribute high-resolution imaging and ultraviolet spectroscopy, which are impossible from Earth's surface due to atmospheric interference. Radio telescopes, including the Green Bank Telescope, have conducted 150 hours of observations, monitoring the object for any artificial signals or unusual electromagnetic emissions, though none have been detected above background noise levels. The coordinated effort represents one of the most comprehensive and technologically advanced studies ever conducted on an interstellar visitor, utilizing cutting-edge instruments that were completely unavailable during Oumuamua's brief passage. Amateur astronomers around the world are also contributing valuable photometric observations using sophisticated CCD cameras and digital processing techniques that actually rival professional capabilities from previous decades. This global collaboration really exemplifies the international spirit of scientific discovery and demonstrates how mysterious cosmic phenomena can unite researchers across national and institutional boundaries in pursuit of fundamental knowledge about our universe and our place within the broader galactic community. 3I/Atlas continues its cosmic journey through our solar system, carrying secrets from distant stars that may forever change our understanding of the universe. Whether it's a natural wanderer or something more extraordinary remains to be determined. What do you think this mysterious visitor really represents? Share your thoughts in the comments below. If you enjoyed exploring this cosmic mystery, like and subscribe to Sci and Y for more incredible space discoveries. Until next time, keep looking up and questioning the universe around us.